Hi everyone, I am Dr. K. Nurul from the Department of Civil Engineering. It is my pleasure to welcome you to today's sessions on linear measurement in surveying. We will explore the foundational techniques and instruments that forms the bedrock of all surveying operations from simple chaining to the use of the compass and plane table. Thank you for being here. To provide a clear structure for our discussions, we will cover the following key topics. We will begin with the introduction to surveying, outlining its professional principles and classifications. We will then dive into the practical aspect of chaining and ranging. Following that, we will explore compass surveying for determining directions. Finally, we will touch upon the plane table surveying for rapid mapping. This progression will give us the comprehensive understanding of traditional linear measurement methods. Let us start with the defining surveying. It is the science and art of determining the relative positions of natural and man-made features on above or below the Earth's surface. The ultimate goal is to represent this measurement accurately on a map, plan or chart. It is the first and most critical step in any engineering project as all design and construction relate to its accuracy. All surveying work is guided by two fundamental principles. The first is the working from whole to the part. This means we will establish a major control framework over the entire area. We then subdivide it into the larger area into the smaller parts. This hierarchical approach prevents the accumulation of error, confining them to smaller section. The second principle is allocation by two independent process. This means a point should always be fixed using at least two independent methods such as intersection and resection. This provides a built-in check for accuracy and helps identifying the mistakes. Surveying can be classified in several ways based on the surface consideration. We have plane surveying, which treats the Earth's surface as a flat for smaller areas, and geodetic surveying, which accounts for the Earth curvature for large areas. Based on the instruments used, we have chain, compass, plane table, theodolite, and so and so. And also we have chain based on the purpose. It has the land, engineering, hydrographic, or even an astronomical survey. Now let's look the primary instruments. The chain, traditionally chains are 20 to 30 meters. They are composed by 100 or 150 galvanized steel links, each 20 centimeter long, connected by oval ring for flexibility, and brass tallies are fixed at every 5 meters for easy reading, and small brass ring are every at 1 meter. These ends are fitted with brass handles, and the total length is measured from the outside of the handle. In the other side, a groove is cut into the handle to hold the small securely. Supporting the chain or ranging rod, there are 2 or 3 meters long poles, circular in cross section, painted with alternative red, uh, white or black bands of 20 centimeter each on the make of them highly visible from the distance. These are used to mark points for the ranging straight lines. Arrows are made of 4-meter thick steel wire about 40 centimeter long, pointed at one end to stick into the ground. These are used to mark the end of each chain during measurement. The other essential tools includes the offset rod, similar to the ranging rod, but used specifically for measuring rough offset to the chain line. Then we have the cross staff, simple but ingenious instrument. It consists of wooden head with two fine saw cuts at right angles. Mounted on iron staff, it is used to set a perfect perpendicular to the chain into from a given point, which is crucially for taking offsets. Objectives of surveying. The objectives of surveying are multifaceted. It is performed to determine the relative positions of points, to prepare plans and maps, and to establish legal boundaries, to facilitate the planning and design of all engineering projects help helps calculating the areas and volumes of earthwork, assist in the practice layout of construction on site, monitors change over time, and provides the fundamental data for modern geographical information systems, or we call it as GIS. A chain surveying in a term effort primarily involves two people, the thrower or leader and the receiver, and we also call it as follower. Moves ahead with a chain, inserts arrows at the end of each chain link and direct to the alignments. The receiver stays at the starting point of each measurement, holds the zero and off the chain, and gives clear hand signal to the thrower to ensure perfect alignment. This coordinates were vital of accuracy. Errors in chain surveying. Despite careful work, error can creep in. These can be categorized into instrumental errors, arise from defensive tool like a chaining that is not of standard length due to stretching or bending or damaged arrows. And also we have personal error or due to the surveyor's clearness, incorrect reading of the chain, miscounting length, poor ranging or workbooking of notes. So next one is the natural error or caused by environmental factors, sag in the chain, expansion due to the temperature, uneven ground or wind affecting the alignment. To minimize error, we must take specific precautions. We have to regularly check and adjust the chain length, ensure proper ranging and alignment. Use a plumb up on sloping ground to project points vertically. Take offset carefully at the right angles and finally record field notes immediately on correct when errors are known, specifically corrections. These are only some corrections. Correction for absolute length, correction for temperature, yeah, corrections for the pull or tension correction, sag correction, slope corrections. Compass surveying, moving beyond more distance, we now incorporate directions with compass surveying. In this method, directions of surveying lines are determined using the magnetic compass. When this distance are still measured with a chain or tape, this allows us to plot the framework of the survey. There are two types of compass. One is the prismatic compass, another one is the surveyor compass. Uh, in compass work, direction is expressed as a bearing, which is the horizontal angle between the line and reference median. The whole circle bearing system measures the angles clockwise from north from 0 to 360 degree. The quadrantal bearing system measures from north or south towards east or west from 0 to 90 degree. A major challenge in local attraction, which nearby magnetic objects like iron ore, electric line, or even as a pocket knife can deflect the compass needle, giving enormous reading. It is detected by checking it the forebearing and back bearing of a line differs by exactly 180 degrees. If not, the correction has to be applied. Compass surveying are typically conducted as a traverse, a series of connected lines. An open traverse does not closes back on itself. Like for the road or pipeline, a closed traverse forms a closed polygon like a property boundaries. However, a compass surveying has limitations. Its accuracy is moderate and it is highly susceptible to local attraction and other magnetic disturbance, make it less reliable than modern instruments like the theodolite or total. This brings us the conclusion of the overview of linear measurement in surveying. These traditional methods, through sometimes supplemented by technology, remain the foundation of our field. Understanding them in crucial are every civil engineers. Thank you for attentive participation. I am now happy to address any questions you may have. Um, Thank you.